This video is going to be about some gravity problems. So let's first start out by investigating objects that we're going to drop. This is like a high building or a high cliff, and here's a person standing there. We're just going to drop it straight down, and we're going to talk about the time and the speed and the distance. So for this particular spot right here, we'll just say that that's at time equals 0, and then the speed, which is the initial speed, we're going to call 0 as well, and then the distance or the displacement that the ball has gone is also 0. So that's pretty good. And let's say that this thing falls down to here, and let's call this spot down here t equals 1 second, right? If we want to figure out how fast it's going, then we have to use our gravity, our velocity equation for acceleration. V equals at plus v0. This a is going to be the acceleration for gravity, so we can put in gt, and then there's no initial speed right there. For gravity, we're just going to call it 10, and so that's going to be 10 meters per second squared times t. So we can see that if I plug in 1 second here, my speed, my velocity is going to be 10 meters per second. If I want to figure out how far it's gone, you have to be careful, because your brain is going to want to think, oh, well, gravity is 10, and that's a second, so it must have gone 10 meters. Remember, if you want to figure out how far something's gone, if it's accelerating, you have to do 1/2 at squared plus v0t plus x0. That's going to get quite simplified because we don't have any initial velocity and we don't have any initial position. So for this particular situation, we can say x equals 1/2 gt squared. By the way, you might sometimes see this as y equals 1/2 gt squared. Right? If you're calling this up and down direction the y direction, that's totally fine as well. And so this is going to turn into x equals 5 times t squared, because g is 10 for gravity. So if I want to plug in 1 second into here, 1 squared is 1 times 5. The distance it's gone is actually only 5 meters. Right? Then if we go down, let's say it's gone down to here, time is 2 seconds. How fast it's going, that's up here, this equation, 10 meters per second squared times 2 seconds. So that's going to be 20 meters per second. And the distance that it's traveled, plugging in down here, 2 squared is 4, 4 times 5 is 20, that's 20 meters. It's just a coincidence at 2 seconds that they're both 20. Moving down, let's say it falls down here, time is 3 seconds. How fast it's going, once again up here, 30 meters per second. And how far it's fallen, have to plug it in here. 3 squared is 9 times 5, 45 meters, right? And then we can keep going on and on and on and on. So remember, we have to use these equations right here if we're going to figure out how far something's gone or how fast it's going due to gravity. Good? Okay, let's move on and talk about if you actually have an initial velocity. So I like to call this one throwing up and down. Let's tackle throwing up first. So still going to have a high cliff, giving myself a little bit of space above the cliff so we can throw something up. And we'll give it this time an initial speed, so v0, and I'll make it a nice multiple of 10 so the math will turn out really easy. Let's say I give it an initial speed of 30 meters per second. And we're just talking about up and down right now. We're not talking about projectiles being thrown. That'll be the next unit that we'll do. So this is going to be at time equals 0. Right? So we're going to go up and then come back down. We'll probably run into some crowding over here and we'll come back down. So this thing's going to go up. We know it's going to be slowing down. So let's say it's gotten there at t equals 1 second. I want to figure out how far it's gone and how fast it's going. So let's talk about the velocity once again. V equals at plus v0. This time we do have a v0 in there. So this is going to be v equals, now this is an important thing that we have to pay attention to. Well, let me just write it down. gt plus v0. We have to pay attention to the direction here. So over here, the ball is going up initially, gravity's pulling down. So we have to figure out which one of these we want to be positive and which one we want to be negative, right? I usually like to pick the positive direction as up and the negative direction as down. That's generally the way that I like to do it. Although if you look back over here onto this sheet, I didn't do that. I actually picked the positive direction as down on this sheet because it just seemed just as easy to keep everything going down as positive. But now that we've got things going in two different directions, I like pluses up, minuses down. You can switch it if you want. Either way it goes. So this is going to mean that the g for gravity is going to be in the negative direction because it's going down. V equals negative 10 meters per second squared plus our initial velocity, 30 meters per second, right? Now if I want to plug 1 second into here, oops, I forgot my t, times time right there. So if I want to plug 1 second into here, that gives me negative 10 plus 30 gives me 20. V is 20 meters per second. If we stand back, it's like, oh, well, that actually makes a lot of sense because gravity is taking away 10 meters per second every second. If you start out at 30 and gravity takes away 10, then you'll end up at 20. So if you want to do the whole equation, great. If you just want to logically think it out, 30, gravity takes away 10 every second, and you go to 20, then we can figure out at 2 seconds, t equals 2 seconds. Plugging it in here, I can do the exact same thing. 2 here, 2 times negative 10 gives me negative 20, plus 30 gives me 10 meters per second. Or I can just think about it logically. Gravity start out at 30, 1 second later you're going 20, 1 second later you're going 10, right? And then I'm going to scooch this guy over here even though it's not going in this direction. So let's say that at t equals 3 seconds, now we know that our velocity is 0. Plug in 3 seconds here, negative 30 plus positive 30 is going to give you 0. Or you can see the pattern, 30, 20, 10, 0. So 3 seconds we've actually made it to the top. At the top it's actually going to start to go back down now, so I got kind of crowded here, so we'll just make it go back down on this side. Now every second that goes by we're going to be adding in 10 meters per second. So if I'm over here, sorry it's getting kind of squished, t equals 4, my v is going to be 10, right? Plug it in here if you want to. Plug in 4 there. Oops, sorry, negative 10. Negative, very important going down, negative 10. Plug in 4 there, negative 40 plus 30, you'll get negative 10. Or you can see the pattern, 30, 20, 10, 0, 10, t equals 5, v equals 20. And the other thing to realize is by the time it gets to 6 seconds right here, oops, negative 20, sorry, negative 30 meters per second. So by the time we've gotten to 6 seconds, we're back at our original height, and we have the exact opposite velocity. So we go 30, 20, 10, 0, 10, negative 10, negative 20, negative 30. And then we can keep going on and on and on. T equals 7 seconds. V is going to be negative 40 meters per second, and so on and so on. Plug it into this formula, it works every time, right? Or you can just think logically. 30, 20, 10, 0, negative 10, negative 20, negative 30, negative 40, and so on and so on. Now we also can worry about the position, where it is at any particular time. Once again, having to do this. Okay, so actually we do have an initial velocity now. And our initial position we can just call 0 as right here at the starting point. So we don't really have an initial position, but we actually do have an initial velocity. So if we want to write this out, keeping our signs as well, this is going to be 1/2 times negative 10 meters per second squared times t squared plus 30 times t. 30 meters per second times t. So x is going to be, just to simplify it, negative 5t squared plus 30t. You have to use this if you want to figure out where you are. Let's figure out for the example of, oh, I don't know, let's figure out at 2 seconds, where is it? All right, so let's plug in x time equals 2. X equals negative 5 times 2 squared plus 30 times 2. 2 squared is 4, 4 times 5, negative 20 plus 60 That's going to give us 40 meters. So we know it's 40 meters at that point. Let's do another one that's interesting. Let's figure out what its position is at time equals 6. All right, so let's do that. X equals -5 times 6 squared plus 30 times 6. That's going to give us, do this calculation out, and you'll find that that's -180 plus 180. That equals 0 meters. You might be, 0 meters? How can that be 0 meters? It went all the way up and down like that. But remember, this is telling you where it is. It doesn't tell you how far it is, how far it went. It tells you where it is. And we know it's at 0 because this is our 0 point right there. Now if we plug in more and more and more time right there, then we can keep going. Whatever time you have, plug it into this formula. It'll tell you where it is. Right? Don't forget your negatives and your positives. And lastly, we can just do a quick example of throwing down. Let's see. Throwing down, similar ideas. Give myself some space. Label this one throwing down. There you are, throwing a ball. Let's give it an initial speed of, let's say, 40 meters per second. Right? Once again, can do all the same things at time equals 1. What's my speed? Well, always can use this formula, AT plus V0, keeping our positives and negatives. This time, actually, since everything's going in the down direction, you know what? I'm just going to go ahead and pick positive as the down direction, because I don't have anything going up, so there's no need to have anything in the up direction. That just means my gravity, my acceleration here will be positive, and my initial speed will be positive. V equals, this is gravity potentially, so 10 meters per second squared times time plus 40 meters per second. And if I plug 1 into there, 1 times 10 is 10 plus 40, that gets me 50 meters per second. Which should also make sense, because if you start at 40, gravity is going to add 10 meters per second every second on the way down. So you start at 40, then you get to 50. T equals 2. V equals 60 meters per second, and so on and so on. Once again, if you want to find the position, 1/2 gt squared plus v0t plus x0. Where's the position? Well, once again, gravity 10, initial velocity 40. I'm choosing my down direction as positive. 1/2 10 meters per second squared, time squared, plus 40 meters per second times t. Right? This is going to turn into 5t squared plus 40t. And wherever you want to choose it, you can plug in a number there. Let's figure out how far it's gone at t equals 3 seconds. X equals 5 times 3 squared plus 40 times, 3, 9, 45. 45 plus 120, it's going to equal 165 meters. That's how far it's fallen after 3 seconds, right there. Good, so we did throwing down, we did throwing up, and then we did free fall, just plain dropping. Next video, we are going to look at some examples with some different kinds of numbers in them.